Welcome or welcome back to Depth First. We are looking at two binary tree problems, diameter of a binary tree and binary tree maximum path sum. One is rated easy on LeetCode, the other is rated hard, and yet the code that solves them is almost identical. Let's start with the easy one. Given the root of a binary tree, return the length of the diameter of the tree. So what exactly is the diameter of a binary tree? The diameter of a binary tree is the length of the longest path between any two nodes in the tree. And importantly, this path may or may not pass through the root. The length of a path between two nodes is the number of edges between them. So the path from node 5 to 8 has length 2. In this tree, one possible longest path is 8, 6, 5, and 7, which gives us a diameter of 3. 9, 6, 5, 7 would also produce the same diameter. Here is another example. The longest path is from node 5 to node 6, giving us a diameter of 4. Notice how the root node 1 is not part of the diameter at all. For a single node, the answer is 0. Alright, so let's figure out how to actually compute this. We will look at this example and let's zoom into the subtree on the left side. For node 2, what is the diameter passing through this node? The left height is 2, the right height is 1, so the diameter through the node is 2 plus 1 equal to 3. And this is the key computation we do at every node. Now the second question is, what do we return upward to the parent? We cannot return the diameter upward because once we move upward, the path can no longer split into two. From the parent's view, this subtree collapses into a single extendable path, which is simply the longer of the left and right paths. That means we return max of left height, right height plus 1. The plus 1 comes from the current node itself since the height includes the node we are currently standing on. Let's discuss the recursive formula. At every node, we compute the best path passing through the node by combining the left and right subtree heights. Then we update a global maximum that tracks the best diameter seen anywhere in the tree. After that, we return the maximum of left and right heights plus 1, since upward recursion can only carry one branch. Let's now review how this recursive formula maps directly into our code. We start by initializing a global max diameter to track the best result across the entire tree. Then we define height of node, the recursive function that drives the traversal. If the node is null, we return 0. Otherwise, we compute the heights of the left and right subtrees by recursively calling the height functions on left and right nodes. These three lines directly implement the recursive formula we just discussed, and finally, we return the maximum diameter we have found so far. So let's change the perspective a little bit. In this problem, the numbers in the nodes are just labels. We were computing the diameter of the tree, meaning the longest path between any two nodes. And those node values didn't matter at all. Now imagine those node values are actual values. And instead of asking for the longest path, we ask for something different. What is the maximum sum of values we can collect along any path in the tree? That is what LeetCode 124 asks us. Given the root of the binary tree, return the maximum path sum of any non-empty path. Let's look at a few examples to understand the problem. So the structure of the tree stays exactly the same, but now we care about the maximum path sum instead of the maximum path length. In this example, one best path is 5, 2, 1, and 3, giving us a sum of 11. But 4, 2, and 5 also adds up to 11, and notice this one doesn't even reach the root. So just like with diameter, the best path may or may not pass through the root. Let's take another example, this time with negative values. The best path here is 15, 27, giving us a sum of 42. Notice it skips the root entirely because negative 10 would only drag the sum down. That's the output we are interested in. Alright, so let's go back to the previous example where we tried to understand the recursive process for diameter. We will zoom into the subtree on the left side again. For node 2, let's now ask a slightly different question. What is the maximum path sum passing through this node? The gain from the left side is 6 plus 4 equal to 10, and the gain from the right side is 5. So the maximum path sum passing through node 2 is 10 plus 2 plus 5 equal to 17. Now, what do we return upward to the parent? We cannot return 17 because that path uses both the left and right subtrees. And a path going back to the parent can only choose one branch. So we return the larger of the two gains plus the current node's value. The shape of the recursion is exactly the same as the diameter of the binary tree, except for a few changes. At every node, we compute the best path passing through that node by adding the node's own value to the gains from each side. We update a global maximum that tracks the best sum seen anywhere in the tree, and then we return a single value upward, the node's value plus the larger of the two gains. Let's review the code. We will start by initializing a global maxsum to track the best path seen anywhere in the tree. Then we define gain, the recursive function that drives the traversal. If the node is null, we return 0. Otherwise, we recursively compute the gains from the left and right subtrees. One thing to remember is that we don't blindly accept whatever comes back from the left or right subtree. If the subtree's gain is negative, it means that the path is actively hurting our total, so we'd rather not include it at all. To handle that, we take the max of left gain and 0 and do the same for the right gain. These three lines directly implement the recursive formula we just discussed, and finally, we return the global maximum sum. The time complexity of both the questions is O of n, as every node gets visited exactly once. The space complexity is O of h, where h is the height of the tree set by the recursion stack. So same recursion, same complexity, one pattern and two classics. Thank you so much for watching this video. If you have found the content helpful, then please don't forget to like and subscribe to this channel, as that really motivates me to create videos like this. Do leave a comment below if you have any feedback. I will see you in the next one. Goodbye.